Okay, so we're moving on to section 10.3, which is permutations and combinations. So these are specific problems that use the fundamental counting principle, but what we can do is we can kind of bypass that a little bit by using the formulas that apply to the particular conditions. So permutations are where you choose elements, and every time you choose an element, the next choice you have one less choice. And also the second thing is that the order is important. Whereas for combinations, the order is not important, so that's like a committee. Whereas permutations are like winning a race, or race places, and picking officers. So we're going to start off with problem number 2, and we just evaluating the expression. So you could use your calculator, but what I want you to do is actually be able to write it out by its definition. And so the permutations are going to be this number here, factorial, and you divide by that number again, subtracting the second number, factorial. So it's 12 factorial over 7 minus 5 factorial, and you do the math. 7 minus 5 is 7, so you get 7 factorial. And then we can rewrite the numerator as such, and we stop at 7 factorial because that is what we're dividing by. So that allows me to cancel those out. And we have 12 times 11 times 10 times 9 times 8 times, that's it, not times anything else. 12, 11, 10, 9, 8, so we get 95,040. Okay. Number 4, we have 14 things taken 6 at a time. This is where order is not important. So we have the same basic arrangement as we do for permutations, but then you divide by the 5, or in this case 6 factorial. I don't know why I wrote 12 down. That's crazy. I was looking at the other problem. That's what I was doing. 14 minus 6 quantity factorial, and then times 6 factorial. So the number you subtract here, you multiply. So we'll get 14 factorial divided by 8. 14 minus 6 is 8. So we rewrite the numerator as 14 times 13 times 12 times 11 times 10 times 9 times 8 factorial, all divided by 8 factorial times 6 factorial. So that product, or that quotient, becomes 1. So we're left with 14 times 13 times 12 times 11 times 10 times 9 divided by 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. So now what we do is we see if we can figure out a way of canceling some of these out. So 5 times 2 is 10, so those can be simplified. Get 10 divided by 10. And then we have 12, which is 4 times 3. And what else have we got here? We got 6, which these have a common factor of 3. So this would become 2, and this would become 3. So I divide both of those by 3. And then this 14 divided by 2 is 7. So ultimately I end up with 7 times 13 times 11 times 3. So the 12s have canceled out. Previously 10s have canceled out. So you have 7 times 13 times 11 times 3, and you get 3003. Okay, then we move on to number 6. And it says determine the number of permutations of each of the following. So all we do now is we take the words and we create a equivalent expression like we just had in the previous case. So The first number is the number of things, which is, we have 15 things taken 5 at a time. This is 12 things taken 5 at a time. This is 14 things taken 6 at a time. So 15 things taken 5 at a time is this, and it's going to be 15 factorial divided by 15 minus 5 quantity factorial, which is 15 factorial divided by 10 factorial. 15 minus 5 is 10. And then we can write out the numerator till we get to 10, and then write it as 10 factorial. And we can see that this is 1. So we just end up with 15 times 14 times 13 times 12 times 11. That's it. And that's what we can stick in our calculator. 15 times 14 times 13 times 12 times 11 is 360,360. And we'll do one more for this video. I got carried away last section. So next one is combinations. So C stands for combinations. 13 things taken 6 at a time. The formula is 13 factorial divided by the quantity 13 minus 6 quantity factorial, and then divide by 6 factorial. So if I didn't have the 6 factorial, I think I just have the number of permutations. What the 6 factorial takes care of is how many different ways you can arrange 6 things. Okay, so that's 13 factorial divided by 13 minus 6 is 7. So it's 7 factorial times 6 factorial. 13 factorial is 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial, all divided by 7 factorial times 6 factorial. This and this is the same, so then becomes 13 times 12 times 11 times 10 times 9 times 8 divided by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Okay, again, we're going to see if we can simplify this. So 4 times 3 is 12. 5 times 2 is 10. Let's just rewrite it here. 13 times 11 times 9 times 8 divided by 6. I mean, that's probably simple enough. You can do it in your calculator, but we're going to do one more thing. We're going to have 13 times 11 times 3 times 3 minus 3 times 3. 8 is 4 times 2. 6 is 3 times 2, so I'm breaking these up. So this group together is 1. This group together is 1. So all I'm left with now is 13 times 11 times 3 times 4. 13 times 11 times 3 times 4 is 1,716. So that's 13 things taken 6 at a time. Okay, so we're going to stop the recording and we'll start a new one.